This video tutorial will demonstrate how to prepare and run a basic AdH model inside of the Surface Water Modeling System, or SMS, which is developed by Aquaveo. AdH is a numerical model developed by the Coastal and Hydraulics Laboratory at the Engineer Research and Development Center of the U.S. Army Corps of Engineers. The first step in building a model with SMS is to import background data such as geographic or location data, topographic data, images such as maps or aerial photos, land use data, and data about boundary conditions. We'll first import survey data, and in this case I have a file all ready to go. But you could import this from a variety of sources, such as from an AutoCAD file or an Esri shape file, or just a delimited text file from a spreadsheet program. Now this data is imported now, and it shows up as a tin or scatter set inside of SMS, and we see it contoured here. In addition to my survey, I'll also import a background image that my tin will overlay on top of. This will help orient me and give perspective to the project area and the model that we'll be building. In this case I have an aerial photo. I could just as easily bring in a map or a topographic image of some sort. We're now ready to create a conceptual model, and I'll start by creating a new coverage and name it a conceptual model and select an AdH as the coverage type. And the first thing in creating a conceptual model is I want to outline the extents of the model domain. And I can do that several ways. I could simply click out feature arcs that would delineate the model domain. Another approach is that I can extract feature arcs along specific contour lines. And that's what I'll try now. So I go back to my scatter data. From the data menu, I select scatter contour to feature. And I select my conceptual model coverage. And I tell SMS that I want a contour extracted along, I want a feature arc extracted along the 271 meter contour, and I'll assign that a spacing of 15 meters, meaning a vertex will be located every 15 meters. I click OK. I'll turn off the image so we can see it a little better, and I have feature arcs created all along the 271 meter contour. Now I have some extra arcs that I don't need. I can go through and delete these, and I go through the process of cleaning this up. But I have a good start for building my conceptual model. For ease in completing this video tutorial, I'll simply delete this coverage and I'll open up a map file that I've already created. And this represents the model extents of my domain. The next step in building a conceptual model is to identify areas and boundaries of different material properties or land use. And a common way to import land use data is from an ArcGIS shapefile. And I'll browse to my shapefile and click Open. And notice now I have a GIS Data folder with my shapefile as one of the layers in that folder. And I can see the areas in my shapefile. Now, to be of use to me in my conceptual model, I need to map my GIS data to a feature coverage to include it in my conceptual model. So I go back to the map module. I'll create a new coverage. I want this coverage type to be an area property coverage, and I'll name it land use. And to map my GIS data to that coverage, I go to my GIS data. From the mapping menu, I select Shapes to Feature Objects. In this case, I'm only interested in getting the material names, so I can have material names assigned to each of those polygons. So I'll map material, click Next, and Finish. And now in my land use area property coverage, I have polygons that came from my shapefile, and they all have different material IDs based on the names that came from the materials shapefile. Now notice that some areas of my models aren't covered by one of the polygons that was in the shapefile. So I'm going to create an additional polygon and additional material to cover those areas. So I'll go and I'll click out a region that encompasses everything else and build polygons. And then from the materials menu, I'll create a new material. In this case, I'll just call it grasslands. Click OK and select my newly created polygon and assign that grasslands material to it. With the domain extents and land use areas delineated, I'm ready now to set the meshing parameters in my conceptual model. So under map data, I'll turn off my land use coverage since I don't need that now and activate my AdH model coverage. And I'll select all of the polygons in that coverage and edit their attributes. First, I'll set the mesh type. For an AdH model, paving often works best since AdH requires linear triangular elements. And then I'll set my bathymetry type. This identifies or tells SMS that when nodes in the mesh are created, that their elevations will be interpolated from my scatter survey or background tin. Click OK. Now I go to the Feature Objects menu, select Map to 2D Mesh, and I want to be sure that Use Area Coverage is checked and that I select my land use coverage so that elements will receive their material type based on the polygons of my land use coverage, and click OK. And now I have a finite element mesh. Before I can run AdH, I need to set material properties, boundary conditions, and time control parameters. And I'll start by setting the material properties. So I'll turn off my map coverage and switch to my mesh. And if I go to the display options, I can turn off the display of contours and turn on the display of materials. So here I can see that each element has been assigned a material type based on that land use coverage that we created earlier. And even though the different materials have been identified, we still need to set the individual parameters for each of these materials. And I do that in the AdH menu under Material Properties. And then for each material I would set a Manning's roughness appropriate for each of those material types, and click OK. And I'll turn off the display of materials and turn back on my contours. Now I'm ready to assign boundary conditions. I'll be assigning a total flow boundary condition at the upstream and a specified head boundary condition at the downstream. And I'll start by creating node strings at those locations, and I want to be sure and include all nodes along the boundary in my node strings. And I'll start at the upstream boundary and specify a boundary condition, and it will be a total discharge boundary condition. And I'll create a new curve and call that my inflow BC, and change my time units to hour and discharge in cubic meters per second. And now I can simply enter in time versus discharge values for my simulation. In this case, I'll simply copy them from a spreadsheet since I already have them here, and click OK. And the process is similar on the downstream boundary condition. I'll select a tailwater outflow boundary condition, a new curve, and again I'll just copy that from my spreadsheet of values. And click OK. Next, I'll set time control parameters, output controls, and other options found in the AdH model control. I'll start in the Time tab, and for this case I'd like to run a simulation that's a dynamic simulation and that runs for 36 hours. And for my time step sizes, I'll use a time step of 10 minutes throughout. Then I'll click on the Output tab, and this controls how often the AdH model will supply solution data. I'd like to start at hour 0 and end at 36 hours, which is the duration of my simulation. And I'd like to see output every 15 minutes. And once I have those values entered, I click the Add button, and this list is populated with all of the output times that I'll get solution data from the AdH model. Now I'll click over at the Global Material Properties tab. Because I have a dynamic model with dynamic boundary conditions, I want to be sure that I've checked this Enable Wetting and Drying Limits toggle, and for this case I'll have a dry depth of 0.1 meter and a wet depth of 0.2 meters, and click OK. The final step before running AdH is to set the initial conditions, found here in the AdH menu under Hot Start Initial Conditions. I have the option of specifying a depth, a constant depth, constant water surface, or from a data set. I also have the option of specifying a velocity initial condition. For this case, we'll just do a depth initial condition. More precisely, we'll start with a constant water surface, and I'll enter a value of 270.24 meters, which represents the elevation of my boundary condition at the first time step, and click OK. Notice now that there's an initial depth data set under an AdH Hot Start folder in the Project Explorer. At this point I'm ready to save a simulation, and I'll say Save New Project, and I'll give it a name called AdH Project. With the project file saved, I'm ready to run AdH, and I do that in the AdH menu, Run AdH. First, a model called Pre-AdH will run, and this checks my input data and my geometry for errors and other warnings. When that completes successfully, I click on Run AdH, and the AdH model will start. Now AdH is a DOS program, and SMS launches that in the background, and output from that model will appear here in what's called the model wrapper. And because I have a large mesh with many elements and I'm running a dynamic model, it'll take the model some time to complete the simulation. So for this example, I'll just abort the model run, and I'll import a solution from a run that I did earlier. So I'll open up the depth dataset file, and this file will give me depths and water surface elevations for every node in my mesh at every time step, or excuse me, every output time set that I specified earlier. And I'll also open up the velocity solution, and this contains velocity vector data for every node at every output time interval. And once those data sets are loaded, I can choose which data set is my active data set, and I can click through the time steps to show how the depth changes over time. In this case, because we have a model that will wet and dry, I want to adjust the contour range so that I'm only showing depths that are positive or above 0, and click OK. And I'll start at the beginning range of my time steps, and as I cycle through them, we can see areas of the mesh beginning to dry out. At this point, you can experiment with the other post-processing and display options, and if you're interested for more information on post-processing and visualization, consult the SMS tutorial on data visualization.